Here we want to find the domain and the range, and in 7 and 8 we have a graph of separated ordered pairs. So one way to approach this is you could list the points in any order. So for the question 7 graph, we have an ordered pair located at -2, -3. We have another at -2, 0. And then we have one that's at 0, 1. And then we have one at 1, 0. And finally 2, -3. Now these points were not connected, they're just separate points, so this is a relation, just a set of ordered pairs. The domain of the relation is the set of the x-coordinates. Now it is repeating the x-coordinate. It is not repeating any x-coordinates. Looks like I have one of these points wrong. So we have -2, -3, and then we have -1, 0. Okay, so the x-coordinates for the domain are -2, -1, -0, 1, 2. The range is the set of the y-coordinates, and that would be -3, 0, and 1. So you only want to list unique values there. This is a function because the x-coordinates are all unique. Now in the second graph, we again have different points that are plotted. They are not connected. So if I list out those ordered pairs going left to right, it looks like I have one at -7, -1, and then I have one located at -4, 4. Then I have one located at 0, 3, and then I have one located at 7, 1. So the domain of this function would be just the points -7, -4, 0, 7. And the range of the function would be the points for the y's, -1, 1, 3, and 4. And this also is a function because all of the x-coordinates are different. Now when you have a graph where you do not have separated points, but it's a connected graph, you're still looking to see that the x-coordinates do not repeat. And one way to test that with a graph is to apply a vertical line test. A vertical line goes straight up and down. Now if a vertical line crosses through the graph more than once at the same x value, then it's going to fail the vertical line test and it's not a function. So let's look at this picture that looks like the graph of an ellipse. For instance, if I pass a vertical line through the position at x equals 3, you'll see that the vertical line crosses the graph twice. Well, the x-coordinate located there would be the x-coordinate of 3. So I have a point at approximately 3, 3, and then approximately at 3, -4. So you can see at that position it's repeating the x-coordinate of 3. So it's not a function. So the vertical line test just lets you visually see if it's going to repeat any x-coordinates, and you're just looking for, does the line cross the graph more than once? If it does, then it fails. This next graph is the graph of a parabola, so it's a U-shaped graph opening up. And if I graph vertical lines all the way through at all points, you'll see that it's never going to hit the graph more than once at the same x-coordinate. So this passes the vertical line test, and so therefore it's not repeating any x's, so it is a function. Okay, if we look at the next graph, we have a polynomial function graph. Looks like a roller coaster. And if I pass vertical lines through it everywhere, you'll see that at no position does the graph repeat any x-coordinates. It's always going to pass that vertical line test, so this is a function. For our last example, we have a similar graph, but it's sideways. So if I pass a vertical line through, you can see here at x equals 2, it's crossing through the graph 3 times at that position. So it's repeating the x-coordinate of 2 right there. So that's going to fail the vertical line test, and so this graph is not a function by definition.